Hear me all right? How's everybody doing? Excited about a networking and security session? More fun than HoloLens, I guess. My name's Yatharth Gupta. I lead the product and engineering teams at Microsoft for Azure Databricks. And we're going to spend the next 45 minutes talking a little bit about security, networking, deployment, architecture. The key goals of the session are, we have a lot of customers who, we launched the service in March. A lot of customers love the service. And they've done POCs. And as they start going into production, they have a lot of questions on how does this PaaS service work? What's deployed where? How can I lock things down? How can I make things secure? And I think that we were so excited about the service that we haven't done a good job in explaining how security works. So this is our attempt to do that. Usually when I do these sessions, both internally and externally, there are a lot of questions. This is a 45-minute session. I'll try to end on time, but I'm going to be available for as long as you guys need me. They're going to kick me out of here, so I'll be standing outside if you guys have questions. So with that, we'll get started. How many people know what Azure Databricks is? How many people have used the service in some format? How many people are familiar with Spark? OK. So we'll do a quick introduction on what Azure Databricks is. When we look at the landscape of big data, and I'm going to presume that folks are familiar with at least the big data landscape. When we look at the big data landscape at Microsoft, what we have found is that our customers are gravitating towards open source technologies for big data. And specifically within big data, specifically within open source, they're gravitating towards Spark. So what we decided to do is we decided to partner with the company that actually founded Spark, the company called Databricks, which is a group of people out of AmpLab Berkeley, and build this service and offer it to our customers. What does it do? Everybody offers Spark. Why is this special? Why should you care? It eliminates all of the DevOps for you. You don't have to manage clusters. You don't have to maintain updates and patches and things like that. And it's designed for the cloud first. Our goal, our fundamental goal is to make sure that when you guys use the service, you focus on your business logic and not on ops. Or at least that's our vision. We're built for the cloud first. We can. It has all the security that comes with Azure. We'll talk a little bit about that. The whole session about that is today. It has AAD built in, which is a big win for our customers. That's something that customers appreciate a lot. Although it's an open source service, you can still log in with AAD, which makes the InfoSec people's life much more simpler because there is one identity authentication system. And it scales. Scale is a pretty commonly used buzzword. I'm pretty sure that every one of the 900 sessions here uses scale. For us, scale means it grows with you, not on some ambiguous meter. It grows with you every minute. So you could start a cluster with just one node and just pay for that one node. And within a couple of hours, you could grow that to a 1,000-node cluster. So you could be processing one CSV file, or you could be processing a petabyte of data. We will grow with you, and we will automatically grow with you. And we will shrink down as well. Everybody grows up, but we also shrink down as well. So you don't need to be worried about how to think about your cluster, how to plan what size it needs to be. Will grow and shrink with you. Three common things that people do with our service. And again, the session is more about security, so I'm going to focus the bulk of time on that. We do have a booth at the expo hall, so if anybody wants more of an intro, there's some great people from my team over there manning the booth, and they'll be happy to go over the service with you. But three big things that people do. If your end goal is BI, if you're from the IT team or if you're from any other product team, if your end goal is BI, Azure Databricks plays a role there. And the way it plays a role is traditional BI is done on SQL. We augment that with other intelligence. People are starting to augment their data warehouses by saying we're going to also get in big data. We might run some machine learning. Maybe we'll just do some ETL. But there's unstructured data coming in. That's where customers use it. Advanced analytics, again, a big buzzword. But when your end goal is you're powering some sort of application, whether it be a web app or a bot or an iPhone app, if the app is based out of data or data analysis, where does that data analysis gets done? That gets done in Azure Databricks. And real-time analytics, so a lot of people are investing in IoT these days. You have sensor readings coming in. You want to do predictive maintenance. You want to do deep learning on pictures of your oil wells, as Shell is doing. There's lots of different use cases where we come in. So with that, with that very basic and quick introduction, I'll start with architecture and deployment. This is one of the most interesting parts of the session because this is not something that we usually publish. Like you cannot go to our documentation and understand how we architect the service because the PaaS service is meant to be easy. This stuff is meant only for you to learn. You don't actually need to know it to use the service. So a little bit of grounding first. For folks that are not familiar with Spark, right? Spark is a scale-out service. Like it's horizontally distributed, so you have one main node, like think of it as one main VMs, and as you grow your workloads, you add more and more VMs, right? This is called a cluster. And I apologize, I know half the folks are super familiar and half the folks are not, so I'm gonna try to land it somewhere in the middle. So you have a driver and you have a bunch of nodes, and all of these nodes work together to do your processing. That processing could be ETL, that processing could be machine learning, that processing could be stream analytics. For the purposes of the security session, it really doesn't matter. So with that, how do we make this a PaaS service? Our PaaS service has three components. At a very high level, there are backend services that we have. There is a cluster manager that we have. And there is these clusters that are actually deployed in your subscription. So when you go to Azure Databricks and you say, I want a cluster, we actually deploy that in your subscription. So you have full transparency in all the VMs that are being used, all the disks that are being used, what's happening. But we manage that for you. So you don't have to worry about shutting down individual VMs or thinking about things like, oh, I have a 10-node cluster. One of the VMs died. Do I need to restart one more? We'll manage that for you. One of them dies, we'll put in another one for you in 6 minutes. So you don't need to worry about any of those things. But three big pieces to this multi-tenant PaaS service, right? Two of these pieces are common across the board, so it's shared across all customers. And where your compute actually happens is specifically in your subscription. The backend service, this is something that you would never see. But this is used for metering. When you run the service, how do we know how much have you used it? We store those logs over there so that we could bill you. We store a lot of our access protocols and our auditing over there because we want to make sure that nobody is touching the service and getting access to stuff that they shouldn't be getting access to. Our service monitoring runs there. So we run a bunch of jobs that continuously poke the service in different fashions, variations to make sure that the service is alive and running. So all of those automated monitoring jobs sit there and run. And this is, again, the back-end part of it. The next part is the control plane. This is an important part. So when you use the service, how many people have created a workspace and launched a workspace? So when you launch a workspace, you see this UI. I'm trivializing by calling it a web app, but you see this UI where you can start clusters, where you have notebooks. All of that lives in our control plane. So anytime you're interacting with it, you're always interacting with our control plane. So we have a couple of things there. In Spark, you have the ability to have a Hive metastore. By default, we have an internal Hive metastore. That's stored in our control plane. All of your jobs that you want to run are stored in our control plane. All of your notebooks and your results from your notebooks are stored in our control plane. Our cluster manager, which is a super powerful component that manages your clusters, is running in the control plane, which is the entity that makes sure that your cluster is right-sized and scales up, scales down, takes care of any errors that happen in the middle. So all of these things are stored in the control plane. But unlike other PaaS services, we are same so far because those two components were multi-tenant components, which is a traditional PaaS architecture. Your actual compute runs in your subscription. So we don't obfuscate that from you. So when you say, I want a cluster of 12 nodes, which is 12 VMs of DS2 V3 type, those 12 VMs are actually deployed in your subscription so you can see them. When we attach a hard disk to it, when we attach an SSD to it, you can actually see that. When we put a VNet around it, you can actually see all of those things. And the reason we do this is it puts us in a unique position where we can offer you PaaS-like service, but with the transparency of you seeing exactly what resources you're using. So you get to see exactly what's happening with the VMs. You can potentially use that to change your configurations, maybe optimize your workloads. It also bills you separately for it. So you can take advantage of discounted billing on VMs through reserved instances and things like that. So that's a brief overview of the three big parts of our architecture: backend services, control plane, and what gets deployed in your subscription. The backend services you'll never see. The control plane you might not realize, but that's the entity you interact with. And the clusters are the objects that are deployed in your subscription. You never interact with them directly. You never go to those VMs directly and submit a job. You submit a job to the control plane, and we take care of orchestrating it through the VM, which is what enables us to put ourselves in a position where you don't have to manage the Spark clusters, right? When you say start a cluster, if you had to start your own VM, then you would have to install your own Spark. Well, we do that for you. Not only we do that, we offer you 17 options that are pre-baked, pre-configured, making it super easy and super simple to do that. Diving a little bit deep into what are these entities in the customer subscription and what do they look like from a slightly different point of view, from a customer view, not from an architecture view. Looks like this. You either come from the Azure portal or through ARM APIs. How many people familiar with Azure portal? ARM APIs? I'm going to presume most of us are. So when you're starting an Azure service, you're coming from the Azure portal or you're coming through the ARM APIs. You come and you create a workspace. Inside a workspace, you have notebooks and jobs and clusters, right? Notebooks and jobs run on clusters. The top bar that you see is what gets actually deployed in your subscription. So if you went and looked at an Azure Databricks resource group, you're going to see all of those entities depending upon how big or small of a cluster you have. Sort of looking into it a little bit, this is what it looks like. When you create a workspace, we create a managed resource group for you. For every cluster, let's say you deploy a one-node cluster, that's going to be one driver node and one worker node. You're going to see a tuple of that cluster node. So it's going to be a VM of the choice that you picked. It's going to be an SSD, it's going to be a networking interface, and it's going to be an IP address associated with that. By default, and we'll dig into this a little bit more, but by default, we deploy your clusters in a VNet that we create that is in your subscription but is managed by us. And the reason we do that, a lot of people ask us questions about that, and we're making some changes over there. But the reason we do that is our goal is to make you productive. Unless you want to manage your VNet, we design it to be secure, and it ensures that you don't break something. One of the common problems that people have when we deploy our managed objects into your VNet is we no longer have control of the VNet, and you might have rules that might unintentionally break traffic to our control plane, and now we can no longer manage your cluster, and all sorts of problems ensue. So by default, we have this deployment where it's our VNet. Make sense so far? Our control plane is geo-distributed. Again, this is something that if you ask this, go and deploy in every region, you're going to figure this out. But what we do is in every geography, we have a control plane, at least one control plane. So US is a geography. We have 3 or 4 control planes in the US. Europe is a geography. UK is a geography. Australia is a geography. Southeast Asia is a geography. And these geographies are defined based on how laws are built. So we never take data out of the geography, which is why we deploy a control plane in every geography. This is important for folks. There are 2 reasons this is important. One, you should know if you're always talking to the control plane, where is it? And if you care about data going out of the geography, you should be assured that that's not going to happen here. The second reason is because our control plane always needs to talk to our clusters, you're going to see a firewall rule that allows the nodes to talk to the control plane. And if you have 2 different workspaces, one in Australia and one in Japan, you're going to see different IP addresses. But today we are in 24 regions and expanding roughly about 6 geographies. So we're available in the US, we're available, if I go this way, we're available in UK, we're available in Europe, we're available in India, we're available in Australia, Japan, Canada I missed, and Southeast Asia. And our next places where we are looking at are the more things like Brazil and France. So if you are our customers and we are not in a region where you think we should be, you should let us know, and we'll continue to work on that. Who has access to the control plane? This is another common question that we get. It's one of those hard questions which I debated whether I should put it on a slide or not. So clearly this control plane is hosted in the Microsoft subscription. It follows all Azure security policies. There are times when we need to access the control plane. If we're upgrading software, if we're building new features, our engineers, a very select few of our engineers, have the ability to access the control plane. It follows all of the Azure guidelines that we have. There is a lengthy paper on it. If anybody's interested, I could share that. Access is only allowed from secure hardware and with just-in-time access. And what that means is none of the engineers who build this service do not have access to its control plane by default. They have to always request access, and permission has to be granted, and it's granted for a limited time bound, right? Without this, we couldn't upgrade the service, or we couldn't run the service, or we couldn't deal with issues. That's why this is needed. Everything's logged and audited. If there are ever any questions around, who accessed the control plane where, I had a workspace and maybe some of my data was there, that's always accessed. That's always logged and audited. So we are very confident that, even though it's a PaaS service, your data is not leaking out anywhere to Microsoft. So to summarize sort of this section, it's a multi-tenant service. The control plane is shared across all customers. So there are parts of the service that are shared across all customers. They're scoped to geographies. Clusters are always deployed in your subscription. Like there's no variations there, or neither are we planning to change that, because we want to make sure you actually get to see the VMs where your code is running, and it's in your subscription, so you can, if you shut down your subscription, nobody else can get those VMs. Access to the control plane, like I was mentioning, is always audited, and it's enforced all the way from like logical security to even physical security. Like there are guidelines that we have that an engineer who's accessing this must be in a building that has secure access. Small things like that we take care of. So that's a little bit of an overview on how the service is architected and how it's deployed. This section should hopefully help you out in when you think about, hey, how do I look at this service? Like what are the different attack vectors I need to look at for my data? This section hopefully has helped you out in understanding how the big pieces work. Moving from architecture, next on, we're going to dive a little bit deeper into security and networking. Have you guys been to any of the other security sessions? Okay, so if you've been to any security session, either they have or they should always talk about security as defense in depth, right? Like that's the core security principle. You have your service, you do data protection, you do access control, you do authentication, and you do network security. Sometimes people talk about it from the other end. I like to start with the data protection piece. So how do we do data protection? This is probably the second most common question that I get, is how is my data encrypted in Azure Databricks? And this is interesting, because Azure Databricks and every other big data engine, when they are deployed in the cloud, the data, your data is not stored in the analytics engine. Your data is stored in a remote storage. And this is a very key point that everybody should understand. Like, let's say you have a petabyte of data or a terabyte of data or even 2 files, right? You don't put those 2 files in Azure Databricks. You put those 2 files in remote storage of your choice. It could be Azure Data Lake Storage. It could be Azure Blob Store. Some customers use Cosmos DB as well. And that's where you secure the data. All of those services have multiple security measures that are available. The most common ones are data is always encrypted. It can be encrypted with your keys, so you can destroy the key and nobody else would have access to the data. And for places like Azure Data Lake Store, you also have file folder level ACLs, where you can actually go and say, here's my data, it's organized into file and folders, and only these users have access to these files and folders. So key point here, in Azure Databricks, data is always remote. Like your core of your data is always going to be remote. But then we get a question, hey, you just spoke about this control plane that had some of the other data parts. They weren't my actual data, but they had something in there. What about that? So we encrypt it with tenant isolation by default, but it's important to understand that that's usually configuration data or maybe little parts of your code. That's not your actual data that you're operating on, which is always stored in storage. We're going to talk a little bit about some of these storage services in Azure offer the ability to only be accessed from a given VNet. So we'll talk a little bit about that in the security section. Data in motion. So the biggest place where data is in motion is when our control plane talks to your subscription to the VMs. That's always TLS. I would presume that everybody would know that, but again, I get asked questions around that, so that's always TLS. Another part that I'm not showing on the screen is when you are in Azure Databricks and you access other services. So Azure Databricks control plane and customer subscription is one path. But you might also access other services like Cosmos DB or ADLS. And all of those services support HTTPS and TLS. So the answer might vary, but it's always secure is the short version of that. So that's data protection. One more part around data protection, slightly deviation from true data protection is what about secrets in the code, right? So you're using Azure Databricks, and you're going to read data from a blob storage or a data lake store. To read data from a blob storage or data lake store, you're going to have to connect to it. No matter how you connect to it, there is some secret involved, right? It's a connection string. Every service has a different connection string. SQL Data Warehouse has a different connection string, but there is secret involved in that. And you don't want that secret in the clear. So what we have done is we've built API surface and features that allows you to secure those secrets. So they're not in clear text. So if an admin says, all of you guys can connect to this data lake store, you can connect to that data lake store, but you don't see the secret being used so that he has the ability to rotate it, change it, build protection around it. And that's been made available. And we offer two choices there. You can either put the secrets in our common key vault, or you can put the secrets in your own key vault. If you put it in your own key vault, you have the ability to destroy it at any point of time if you see some malicious activity going on. So in addition to data protection, this is the one other small piece that we add at this section. So going down our list, this is just how you create, it's called a secret scope. It's how you create a secret scope. I've put in links. A lot of these things I've found is valuable information for people to hear, but then they also want to go back and read more about it when they actually want to use it. I'll make sure the deck is posted, and I see people are taking pictures. I should have maybe made a short link, but all of this is available in our documentation. So going down from data protection to access control. This is another very interesting area. The fundamental security guidelines is people should only have access to what they need. How do you set that up? That's a very open-ended statement. So if we start with data protection, you can go into Azure Data Lake Storage and say these files are only available to these users. What about the rest and the analytics engine? We have 3 or 4 things where we have built in very rich RBAC control. Notebooks is our primary way where interactive users write codes. There are jobs that you can submit. There are clusters, which is the actual compute that can run. And a lot of our customers care about RBAC around that because they don't want every data scientist starting a cluster, because a cluster is the only thing you get billed for. So a lot of customers want to make sure that they have an admin group or a select few group who can start a cluster. A lot of people can use a cluster. So we have RBAC built in for all of these things. We'll start with folders. So our notebooks are organized into folders. In folders, we have the ability to do RBAC both from the UI and from the API. So you can have read, run, edit, manage permissions, and this would mean that all of these would apply to all of the notebooks in there. If you look at notebooks, look at the granularity, right? Like if you have, you can view cells, you can comment on cells. The permissions differ. So you would either set a read, run, edit, or manage permission on each of the notebook. And this would allow you to say that only a select set of users can perform certain actions. There are many cases where, like, let me give you an example. One of our customers has written, custom machine learning algorithms to be used by the rest of their company. So there's a core group of data scientists who've written these custom machine learning algorithms, exposed maybe some of them as helper functions. And they could have just given this to the rest of the company as an API, like call this, import this and call this. The challenge with that is everybody wants to know more. Like they want to see how it's working so they can optimize their code. Well, if you give them access to the notebook, the number one problem that happens is they go and change it. And now it impacts many other people. So you have the ability to give read permissions. That's a very common example where read permissions are given. You can even leave comments. So again, I'm trying not to overpitch the service, which is what I usually do. But the service is designed where the notebooks are collaborative, so people can go and leave comments in there as well. This is all it takes. Like you go to a notebook, you create a workspace, You open a notebook, you go to a notebook, you can go and set, who has permissions to do what. It's really like we have worked extremely hard, and you guys will tell us whether we have succeeded or failed. But we have worked very hard to make sure that you have the security and the flexibility, but it's also simple. Like we don't want this to be so hard that you need a whole engineer to set up your security, because that kind of defeats our purpose of enhancing the productivity by making it super easy to get started. You can do the same thing for jobs. You can see who can view the jobs. Mostly in jobs, it's mostly about viewing the logs. So you can set that up. You can see who can run the jobs versus just view them. So you're able to set that up for jobs as well. And we're constantly looking at this. We want to make sure that we make more granular permissions. We think we've settled on this. We think if we make it any more granular, it becomes too confusing. But if there is something that is missing, that you feel like this absolutely should be there because it's a key scenario of mine, we would love to hear about that. Clusters, this is the one that is probably the most used permission. So people set up notebooks, to make sure that people don't accidentally edit notebooks, that people have access only to some notebooks. But cluster control is something that's used a lot by our customers, because there are plenty of customers who say only some people can start a cluster. Only some people can, use a cluster. And this is done for various reasons. Every company is, in their own way, distributes it amongst departments. They only want maybe their department tech leads to start the clusters. There's a cost control also associated with it, right? Because clusters, again, like I mentioned earlier, is the thing that costs you money. The rest of the things, they're for protection, but this also has a monetary dependence of things. So that was notebooks, jobs, clusters. We call all of this access control. The next one is going to be slightly different. The next one is tables. How many people familiar with Spark tables? How many people familiar with Ranger? Okay, so we don't have Ranger support. We could talk about that in detail, but in Spark, when you load data, users typically create tables. Data is you create tables, so there's a metadata store, and tables contain references to the data. We have built-in access control for tables, because a lot of customers want to make sure that some of their engineers can only see some tables, right? You have PII data. You don't want every engineer to be able to see it, or you want to, there are cases where we are working with companies who want to make sure that certain, how do I say it, area salespeople only see their customers' data. Because apparently if they access other people's data, they're going to start poaching those customers. So there's a number of reasons why this security is important. And we've made sure that, in the table space, you can put permissions on catalogs, databases, tables, views, functions, or just anything. And there's a rich set of privileges. I think I'm missing one, but there's a rich set of privileges that are available. That's when I first looked at that slide, I'm like, whoa, like, am I making it easy? So here is the way to think about this. You can grant or deny on a specific object to a specific user what privilege you want to give. So I could, create a table and say everybody that attended this has access to that table with read privileges. That's the way to think about it. We have both, again, grant or deny, so you could go in either direction. A couple of things that we have done to make sure that this is not just something at the high level, right? Because one of the things that happens in big data is, again, compute and storage are separate. There are lots of low-level APIs. I could give you ACLs on the table, but then your user goes and calls a low-level API to access that data, kind of defeats the purpose. So access control for tables is only available when you're using SQL and Python. The Python part is in beta. So when you go to create a cluster, there's something called a high concurrency cluster. And what a high concurrency cluster does, amongst other things from a security perspective, is it has user isolation. And when you say I want table level ACLs, you can only write SQL queries or Python queries in that cluster. Because we are able to isolate SQL and Python to a level that no matter what low-level API you use, these permissions are adhered to. If we say, for example, allowed Scala on that cluster, a smart engineer could call an RDD, which was backing a table, or could call the underlying storage that was backing the table and access that data. So we don't want to do that. We're starting with SQL and Python, which is the most commonly asked things for table level ACLs, and we're going to grow it from there. It's easy to set up. Again, taberacles aren't enabled by default. You have to enable them because it puts some restrictions in there. So when you're creating a cluster, just go and say, I want a high concurrency cluster. I want to enable taberacles. And then you can issue those commands on who has access to what. So we went through data protection. How do you secure your data? We went through access control, like the rich RBAC ability that you can use to make sure that you're only allowing people who need access to have access, not a scheme where you say if a user has access to this workspace, he has access to everything. That would be bad. The next one is also my favorite one, authentication. This is something that I am super proud about. One of the biggest challenges in the open source space is authentication. Like everybody has some sort of identity. If you're on Azure, there's almost a certainty that you have Azure Active Directory or some sort of federation with it. And there are big teams or maybe small teams in some cases who manage identities of users and what they can do. So at Microsoft, I am YA Gupta at Microsoft. Somebody knows that. Somebody knows what I'm able to do and what I'm not able to do. But when it comes to using open source engines, in any cloud, what happens is that identity gets a toss because open source engines work slightly differently. We have made sure that the only way to authenticate to Azure Databricks is AAD. It's not something that you can do. It's the only way to do it. And you don't have to click 7 buttons or configure IAM roles like in some other services. That's how you come into the service with AAD. So that makes sure that if you're working in IT, you don't have this secondary headache of, there was a second identity system. How do I keep them in sync? What happens when somebody leaves the company? Did I remove him from a second identity system? How many places is this thing managed? What tools do I buy to use and sync all of these? When one of the identity systems has a new feature, does the other one have it? You don't have to worry about any of those things. We have also enabled conditional access. And this is one of the advantages of going with AAD. As AAD innovates, I get to claim that we built new features and provide more value to you. So with conditional access, what happens is, for example, let's say if I were at Microsoft, I could set a policy that says every user, when they are coming from an IP address that is associated with this event, have to have multi-factor authentication, or they don't have to have multi-factor authentication. Or anytime they access from this other country, they have to go through these secondary checks. I'm not going to go into all the details of conditional access, but it allows you to set up additional security features to mitigate your risks. If your employee is trying to access this workspace from a country that you wouldn't expect, maybe he has to go through some additional checks, or maybe you disallow that. You can set all of those things up in conditional access, and we fully support that. So if you're using AAD identity, you have conditional access, you get all of these things sort of by default. So this is something, if you have played in the open source world, this is a non-trivial thing, and it adds a lot of benefits because not only did we authenticate using AAD, when all the role-based access that I was just talking about, I could just assign it to AAD users. I don't have to assign it to some other user that I created and maintained. And at the end of the day, I've seen people keeping Excel spreadsheets of what user maps to what real person. So none of those problems here. The last layer, so data protection, access control, authentication, network security. Network security, we have 2 options, and we're super happy to announce one of them here at Ignite. The first one is managed VNets. When you create a workspace, any cluster that you create within that workspace, we've created a VNet for you. We manage that VNet. We deploy all of the clusters in that VNet. We think that this makes your life simple. But my customers disagree with me, so we'll give you a solution for that as well. This is what the default looks like. So the core part of the VNet is the NSG rules. So we have NSG rules that allow inbound traffic from our control plane to the cluster. So you can see that that 40.address is likely the US control plane that's being able to access the cluster. That's how we manage your cluster. There's a couple of other rules. We, of course, allow all outbound rules. What are the common challenges with this? Like when we built this, we thought this was a brilliant approach that you won't have to worry about it. And we also enabled peering. So you might want to peer with your Kafka cluster or other things. We thought this would fix all of the world's problems. But customers teach us all the time, and we are fascinated by that. What we learned is people want application layer firewalls. They say, hey, I'm going to get packages from the internet. Maybe I want an application layer Palo Alto firewall, if you're familiar with that. And if I want to be able to do that, I need to be able to crack this NSG. Well, the NSG is in my subscription, but I can't crack it because it's managed by you. How do we solve that problem? There are so many scenarios for user-defined routes that I didn't imagine that customers want. So what we're announcing today, well, we announced it 2 days back, is you can sign up for VNet injection. You can tell us that we do not want your VNet, Microsoft, that you set up for us. We want to deploy in our own VNet. The advantage of deploying on your own VNet is, again, you can use service endpoints to restrict access to storage. You have a storage service that says, I only allow I only allow transactions from this VNet. You could set that up. You could set up, UDRs. You could set up firewalls. You could set up multiple other configurations. This is now going to be possible. The one challenge that comes with this, for full transparency, is when we allow you to deploy on your VNet, when you start, we will give you a list of rules, and you will likely set them because it won't work without it. Sometime in the future, you're going to change one of those rules, and it's going to break, and you're going to be mad at us, and you're going to call us. We're working on a fix for that problem, but that's the reason this feature is in preview. There was a lot of discussion on we should release it. It's ready, but we held a line. What we are going to do, and I always get into trouble for making pre-announcements, but who cares? What we are going to do is we're going to work with the networking team to come up with a technology that allows us to deploy on your VNet with the rules that we want. And when you create a rule that is going to break you, we'll let you know about it. So we're working on that. Once we have that enabled, we're going to make this feature generally available. But with that configuration, we're pretty confident that we put you in a good spot, because the last thing that we want is you breaking something. And it's not going to be the guy who is using Databricks, right? It's a VNet that's shared by multiple people in your organization. New security guy joins the team. He looks at some of these IP addresses. What the hell is going on? I'm going to stop this. And jobs start failing. We want to avoid that situation. But again, if you need it, our recommendation is if you need the flexibility, then go down this route. Otherwise, the other approach of where we deploy it in our VNet works great. So data protection, key thing to remember is storage and compute are separate. Like thinking about data protection in Azure Databricks, you're asking the wrong question. The question you want to ask is, where is my data stored? Is it stored in blob storage, or is it stored in Azure Data Lake Store? And you want to protect the data there. And those guys have really good ways of helping you protect the data. Encryption, customer managed keys. Access controls, super rich RBAC. Maybe our biggest problem is the discovery of that RBAC. So we'll make some, we do conferences like this. We'll maybe do something in the UI of the product, but we have super rich RBAC. If you are a customer and somebody in your company is asking about Ranger control, let's demystify that, right? What does Ranger control allow you to do? You want table level ACLs, we got table level ACLs. You want to control who has access to the raw storage, you can do that using Azure Data Lake Storage. Authentication, simple, always AAD. No other option, with one caveat, of course. When you are using our service, you can use it as a user, or sometimes you want to use it from an API. The API uses a token to make it simple. So you, as an AAD user, log in, generate a token, and then use that token to connect to an API. We're going to fix that soon, but it still starts with AAD. Network security, 2 options. Unless you have a need, choose the default option. That's the only option you'll see in the experience and through the ARM templates today. But if you do want VNet injection, go to that website. There's an email form. Fill that up. We'll set you up with that. So that's a little bit about network security, networking and security. Looks like it's yellow, so I have about 5 minutes left. And I have one topic, and then I'll take some questions. This is simple, easy one, compliance and SLA. We're a service that GA'd in March 22nd of this year. So, we're not that old. So our compliance list is growing. We have 27001, 27018. We have HIPAA for all of our healthcare customers, and we have SOC 2 Type 2. If there is a compliance requirement that you have, please do reach out to us. You can email me if you work with somebody, one of the CSAs from Microsoft, let them know. what requirements you have. Because we are only prioritizing based on what customers want. Like we don't have any grand vision or grand plan of, oh, I think I need to fill up my compliance slide. We go where our customers want. High trust is something that keeps coming up. There are a few others that keep coming up, so we're prioritizing those, but we'll listen to our customers. From an SLA perspective, we have a pretty good SLA with 99.95 availability. We're pretty good at meeting that as well. Won't go into all of the details, but rest assured, like the service doesn't go down. There haven't been like these massive, you cannot access the service anymore. Of course, it's a cloud service. Of course, there are going to be incidents. We have a rapid response team that makes sure that all of them are dealt with in a quick and easy manner. So with that, I want to make sure, well, we'll keep maybe more than 3 minutes for questions. But just a summary of this, hopefully you understood the architecture. And even if you didn't understand it in detail, hopefully you understood enough to know what to go and look for or how to think about this. Security, I intentionally made it super simple. Like I was thinking about, should I go in all of the complexities of it? But I think that it really is those 5 things. Like think about it, think about data protection, think about access control, think about authentication, think about network security. If there's something we didn't cover, let us know. We'll make sure that that's covered as well. Compliance and SLA, again, we have those 4 compliance listings right now, and we have 99.95 SLA. With that, I'll take questions, but before I take questions, I have somebody sitting there who cares very much about making sure the session went well or bad, but we know how well or bad it was. So whenever you guys get a chance, please do fill out the Q&A. Please do fill out the evaluations. Rest assured, I read every comment. So, if you don't like the color of my shirt, even that works. Please don't complain about the AC, because I can't do anything about that one. We've seen a couple of comments on that. Go ahead, sir. Can we get the mic on, please?
Not sure if that works. Okay, that works. Fantastic. Fantastic progress, especially on the security side. Do you have in plans support for MSI in order to not to maintain secret?
Yes. I won't go into, I won't make commitments, because then you're going to hold me to it, and I have no way to update you on everything that happens. But I can tell you that MSI is amongst the top 5 things that we are looking at from a security perspective. The reason where MSI is important. Let me ask you this question: where do you need MSIs?
Primarily to access storage accounts, just so that we don't maintain keys. Our InfoSec doesn't like when we maintain keys, even key vault.
So you want to access the storage accounts using MSIs, and you would give the storage account access to that MSI. Yeah.
Exactly, yes.
Yeah, we should have that available. Though with the secret scopes, right, where you can put it in the keyword, I guess you're saying your teams don't like that approach.
Yes.
Yeah. All right, cool. So it's coming. If you could use the mic, that would be very helpful so everybody else can hear the question.
Again, this was a great session. My question is very simple. So the first question is, the kind of tests the control plane handles is just basically like adding more machines to your like resource group when you want to scale your cluster, or
no, that's one part of it. I won't quite trivialize the control plane to that small. So one of the components that you saw on the slide was the cluster manager, right? It manages your cluster. One of the activities in managing your cluster is adding VMs when they die. But it also manages auto scaling. It monitors your cluster to make sure that you are at size 7, you have auto scaling set up. It can grow and shrink. It also manages the fact that when VMs accidentally die, we bring them back. So there's a lot more things that it does, and cluster manager is just one component.
Do we have, so like I see VMs on the resource group, so do we have access to those VMs, or they're pretty much locked?
So access is a challenging word there. Those VMs are your VMs, but you cannot stop them. Because if I let you stop them, then it becomes very hard for me to maintain the cluster. You can see them, but you cannot manage them. We manage them for you.
So say like I'm done with my jobs and I want to...
We will take the VM off.
Okay.
Yeah. We'll clean, and if the VM doesn't clean up, you file a ticket and tell us what the hell are you doing and also ask for a refund, but the VM will clean up. I'm pretty sure. Yeah.
quick questions on. So, is there a way to make public endpoints available? The network security groups helps. NSGs is good, but having a proper like laid out to say this is the all it needs to call out to, like a control plane or anywhere else.
So you're saying, if I understand the question correctly, and tell me wrong, you want a list of fixed outbound rules.
Outbound rules, or at least the URLs or IPs.
Yeah, so there is a challenge with that. So again, for the small audience that is left, there's inbound rules and outbound rules. Inbound rules are very tightly controlled because we want nobody to come in except the control plane. So that one's easy, that's done. Outbound rules are challenging for us. Outbound rules are challenging because we give you the flexibility to install, let's say, TensorFlow. We give you the flexibility to install the PyPy package we just released for something. Okay, let's take that problem and limit it to PyPy packages. There are a lot more things. When you limit it to PyPy packages, now PyPy packages are hosted on a website that is globally distributed using a CDN. So there is no way I could authoritatively tell you, like these are the things that it absolutely needs because some of it depends upon what you do. If you chose not to have any libraries, right, we could probably work with you to come up with a list. Yeah, if you said that in my use case, I will never call out to any other service in the world, right? Which would be, a use case that I haven't seen, but we could work with you to come up with that list.
A little differently, and so if we say out of the box, this is what it will do, right? And then you can add a tag on to say, then if you add other libraries and all, then yes. But here is what by default, but don't do anything. This is all it will talk to.
Our problem is that very few customers use it without libraries. But I understand your general sentiment. Let's see. Let me go back and think a little bit more about that. I'm going to take the question there and then come back here.
Ben, first, thank you for this large presentation browsing for security. I have one question around the blob storage and the storage of the data within Databricks. As you have access using an SSH port, do you have access to the blob storage and the data?
Do I have access to a blob?
To the blob storage, which is in the managed resource group.
Yes, we do have access to
in that case, in a regulation world, you should have not a certification, but you need to make a paperwork with the entities allowing you to be data processor.
So the way we look at it, and again, we can go into some of the details offline, but at a very high level, you're absolutely right that the managed resource group comes with a blob storage. And we have chosen to expose that blob storage. But we absolutely do not recommend that you put your data in that storage.
But as soon as I use the cluster, if I use the cluster and I make a table where this table is stored?
If you make a table, so there are two parts to the table in Spark, right? There is the metadata, which is stored in the Hive metastore, and there is the actual data, which is stored in your remote storage. So the Hive metastore says, here is the schema of the table, and the data points to some CSV file that is not in the blob storage that we own, that is in the blob storage that you own.
Is there any data, is there any customer data stored in this resource group?
So depending upon the definition of customer data, for example, when you download libraries or set up configurations, some of that is stored there.
Okay. I'm happy to have a discussion of
absolutely.
I need to have it to make it sure that it's compliant with my
Yes, we should absolutely have that discussion. Thank you.
Hi, I got two questions. The first is kind of on, I've set up a lot of my ACLs down at the directory level within ADLS or something. Is there going to be on the roadmap anywhere to do kind of a pass-through down so that security is handled down at that layer?
Yes. That is, hopefully they stopped the recording. That is also coming soon. That's something that we very much care about. And let me give you the reason why that's a little bit challenging, because it's one of those things that you would expect. Why is it not there on day one? Like, what the hell? The reason that's challenging is, let's say there are 3 users using the same notebook and the same cluster. The notebook's attached to the same cluster. Those 3 users have different permissions. We want to make it we want a scheme where we say that those 3 users cannot access each other's information, although they are in the same notebook. We could solve this problem very easily if every user had their own notebook and their own cluster. We want to do a little bit better, but we are very actively working on it. It's one of the top issues.
I spent a lot of time putting ACLs together down at ADLS,
we hear you.
directory structure, and can't use that, right?
Yes.
And so the second part is, what about Active Directory groups?
That is also coming early next year.
So those are my 2 big ones.
Yeah.
Thank you for the session. Your recommendation was Azure Active Directory, right?
Well, that's the only way we log in. So
Okay,
it's
so
more of a requirement than a recommendation.
So ADFS is not going to work.
ADFS?
Yeah, Azure Active Directory Federation Service.
So we always connect with Active Directory, and I might not be the right guy to go into all of the technical details, but if you federate it with your identity, like if you federate it as Active Directory, that should work. But I will have to follow up. I don't want to make a commitment here.
Yeah, so I wanted to understand, do we need to enable the password hashing in the Azure Active Directory? Or no?
I will have to get back to you.
Okay, all right, thank you.
Any other questions? Thank you very much. I had a lot of fun. Hopefully you guys did too. Thanks.